Welcome to my presentation. I am Julius Dada. Today my presentation will be on integration, whereby you note that in the process of presentation, I will apply laws of indices and algebra. Welcome. Laws of indices. When we have the base being the same, a to power m times a to power n, we always add the power so that we get the result as a m to power n plus n. When you have the division sign and the base is the same, we subtract the power, so we get a to power m minus n. When you have the base and we have the power, then into bracket another power. To open the bracket, we always multiply m times n and we get a to power m times n. When you have the power as negative, it is the same as 1 all over a to power positive n. So now the negative now disappears. We have 1 all over a to power n. When you have a fraction a divided by b, a over b, yes, divided by c is always equal to a divided by b times 1 all over c. For any absolute value, you will cite in my presentation is that for every absolute value noted as a with two parallel lines is always equal to a. And when you have negative a and the two parallel lines is always equal to a, because when it is absolute, we always take the positive value. Integration is the process of obtaining the expression of y in terms of x, given the derivative, or what we call the gradient function. For example, when you have y is equals 5x plus 3x plus 2, the gradient function, which is dy dx, is given by multiplying the coefficient of x by the power of x, that is 5 times 2, and then reducing the power of x by 1, 2 minus 1. And then you do the same to the next term. So you'll have 1 times 3, which is 3. Then the power of x was 1, we reduce by 1. So you get 1 minus 1. Therefore, dy dx will be equal to 5 times 2, 10. 2 minus 1, 1. So 10x to power 1. And in the next term, it is 3x to power 0. So that is what we call the gradient function. So given the gradient function now, because we have already said that integration is the reverse of differentiation when we are given the gradient function, now we can start now from the gradient function, and then you get the expression of y in terms of x. How do you reverse? To get the gradient function, we have reduced the power of x by 1, and we have multiplied the coefficient of x by the power of x. So now to reverse, we need now to increase the power of x by 1, which is it was x to power 1, so we increase the power of x by 1, and then we divide by the new power, plus 3, the power of x was 0, so we add 1, we divide by 1. So we get our expression of y in terms of x as 5x squared, because this 2 divided by 10 divided by 2, you get 5. 1 plus 1, you get 2, plus this is 3x, 0 plus 1 is 1, so you have 3x. We always add a constant c, because c can take any value, and we call c an arbitrary constant. The expression y is equal to 5x squared plus 3x plus c is called an indefinite integral, because it does not have limits. We need the limit to solve for c, which is our arbitrary constant. The moment you see this sign, it simply gives you instruction to integrate. All these we are integrating with respect to x. So it's a function of x. Now we proceed. We increase the power of x by 1, so this becomes 4 plus 1. Then you divide by the new power, which is 4, plus this is 6x. You increase the power by 1, then you divide by the new power, plus 2x. You increase the power by 1, then divide by the new power, plus 5 is assumed to have x to the power 0. So we add 1 and divide by 1. So eventually we get x to the power 4 plus, divide by 3 you get 2x cubed, plus divide by 2 you have x squared plus 5x. Remember, there are no limits, so we must add. So we already have now our integral function. So our y is equals to x to the power 4, 2x cubed plus x squared plus 5x plus a constant. You can integrate term by term. Given an expression that have various terms, you can integrate term by term and then you add to give you the same answer. Remember, we still have, because we have a c here, it is still an indefinite integral. Let us now think of a definite integral where we have the limits. Function as 2x plus 3 dx. So what happens when you have limits? When you have limits, now it is no longer an indefinite integral. It will be a definite integral because it will be having a limit from the lower limit of -1 to the upper limit of +3. So let's do it. So we move on, increasing the power of x by 1. So x1 plus 1, dividing by the new power, then plus 3, the x is to power 0, plus 1, divide by 1, so you'll have 2x. So this follows here, so you'll have x squared plus 3x. We'll have the range starting from -1 to +3. Then we need to substitute. We substitute because the range, the highest range is 3, the lowest is -1. So we'll get the highest, we subtract the lowest so that we get the range that is there in between, the integral that is there in between. So this will have 3 squared plus 3 into 3, all this now we subtract -1 squared plus 3 into -1. So that's what we have. Opening the bracket now, we have the bracket now we have 9 plus 9, so that is 18, minus, we have a bracket here, this is 1 minus 3, this is -1 squared is 1, plus 3 times -1 is -1, so we'll have 1 minus 3. So it will follow to be 18 minus -2. So minus and minus becomes plus. So you get the solution as 20. And this is what we are calling the definite integral, because we are getting the solution as 20. In the sketch diagram, you asked to find the area under the curve y is equals to 2x plus 3x squared, x is equals to negative 2 over 3, and x is equals to 2. So we want to get the shaded area, finding the area under the curve. Now, when we have two areas, that one is below the x-axis and the other one is above the x-axis, we calculate the two areas separately. You cannot just start from the limit as, you cannot take the limit as negative 2 over 3 to 2. We cannot do that because one area is below the x-axis and the other area is above the x-axis. So we have to separate the two areas independently. Negative 2 over 3, 0. That is 2x plus 3x squared dx. Then we add the other area. That is 0 to 2. So we have to calculate the two areas separately. Let's do the first one. We'll have now, start with the first one. This now we'll have the range as from negative 2 to 2 over 3. The range is from negative 2 over 3 to 0. Then we integrate the function. So this will be 2 into x 1 plus 1, that is 2 divided by 2, plus this is 3 x plus 1 divided by 3. So we'll get the integral function as x squared, 2 will cancel with 2, 3 will cancel with 3, plus x cubed. This is what we have. Substituting the upper limit, then we subtract the lower limit. We have x cubed plus x squared plus x cubed. We have the limit from negative 2 over 3 to 0. Substituting 0, because the higher limit, we'll get 0 squared plus 0 cubed, that is 0. Then we substitute the lower limit, which is now negative 2 over 3 squared plus negative 2 over 3 cubed. Which gives us now, down here, we have 0. We want to work out the other side. So this is minus. This is negative 2 over 3 squared, that will be 4 over 9. Negative 8 all over 27. Negative plus negative is negative. So we have now the LCM of 9 and 27, which is 27. So follow me up here, we'll have 27 divided by 9 is 3, so multiplied by 4, we have 12. Minus 27, that is b minus 8. So you'll have 4. So this gives us 0 minus, this is 4 over 27, which gives us negative 4 all over 27. We are through with the part that is below the x-axis. Area below the x-axis will always give us a negative value because it is below the x-axis. But we always take the absolute value So it will be 4/27. Because the negative sign simply means it is below the x-axis. We need to do the other part that is above the x-axis, which has the limit of 0 to 2. So the next part now we have, it has 0 to 2, it will be x cubed, x squared plus x cubed. Our limit is 0 to 2. So this is now, when you substitute, you'll have 2 squared is 4 plus 2 cubed is 8. That is, when you substitute 2, then you subtract. When you substitute 0, it will be 0. So this gives me 12. So the area under the curve that is above the x-axis has an area of 12 square units. The other one has 4/27 square units. So we need now the shaded area. The shaded area will be given by 12 plus 4/27, which is equal to 12 and 4/27 square units. Area is always in square units. So the area under the curve bounded by the x-axis, and the values of x is -2/3 and x is 2, will give us 12 and 4/27 square units. That's how we get the area under the curve using integration. We have noted two things, that when the area is, one part of the area is below the x-axis and the other one above the axis, we calculate the two areas separate. The next thing to note is that when the area gives you negative, it means the area is below the x-axis. So you ignore the negative sign, you get the absolute value of that negative, which is 4/27, and you get, then you have the two areas and you get the solution. If you enjoyed this, don't forget to like, subscribe, and hit that notification bell for more maths adventures. Drop your questions or topics you would love to see next in the comments. I would love to hear from you. Until next time, keep solving, keep exploring, and I'll see you in the next one.